Imagine a cataclysmic explosion so powerful that it can outshine entire galaxies for a brief moment, sending shockwaves across space and time. This is not a scene from a sci-fi movie. This is the reality of a supernova, one of the most magnificent phenomena in the universe. But how do these stellar explosions shape our cosmos? What secrets do they hold about the birth and death of stars, the creation of elements, and even the framework of our universe itself? Stick around, as we embark on an incredible journey that will not only expand your understanding of these celestial events but also connect to the very essence of our existence as cosmic beings. Picture this: in the grand expanse of space, countless stars are born, live their lives, and ultimately meet their end. Some stars go quietly into the night, while others, like massive supergiants, blaze out in a momentous display of light and energy. These spectacular events, called supernovae, are not just fiery flares of stellar energy, they are cosmic alchemists, transforming dilute pockets of hydrogen and helium into the heavier elements that make up our world, and indeed, our very bodies. Yes, you heard that right. The iron in your blood, the calcium in your bones, and even the carbon that composes every living organism were all formed in the hearts of stars that exploded billions of years ago. Isn't that astonishing? But there's more to the story. Supernovae have profound implications for the universe at large. They are responsible for distributing these newly created elements throughout the cosmos, seeding the formation of new stars and planets. Without supernovae, the universe as we know it, teeming with life and complexity, simply wouldn't exist. So how do these mighty explosions orchestrate cosmic evolution? Join me as we peel back the layers of this mystery. First, let's delve deeper into what a supernova actually is. In essence, a supernova occurs at the end of a massive star's life cycle, a phase marked by dramatic gravitational and nuclear processes. You might be wondering, how do these cosmic giants generate enough energy to explode so violently? It all begins with nuclear fusion. When a star like the Sun fuses hydrogen into helium, it releases an incredible amount of energy that keeps the star stable. But what happens when a star exhausts its hydrogen fuel? In a massive star, as these nuclear reactions draw to a close, the core collapses under its own gravity, creating conditions of extreme heat and pressure. Once this core becomes sufficiently hot, helium and heavier elements begin to fuse, creating even larger nuclei until it reaches iron. Here's the shocking part: iron fusion is not an energy-producing process. In fact, it consumes energy. This is the tipping point where things start going terribly wrong. As the star can no longer thermally support itself against the relentless gravitational push, it ultimately leads to a spectacular collapse, followed by a catastrophic rebound, thus, the supernova explosion. You may find it startling that while supernovae are indeed cataclysmic events, they often occur in what seems like an instant in cosmic terms, but the aftermath resonates throughout the universe for millions of years. The energy released during a supernova is extraordinary. In fact, a supernova can briefly outshine an entire galaxy. Imagine a single star casting light so bright that it momentarily overshadows billions of its companions. What's even more remarkable is that in those fleeting moments, the elements forged in the crucible of that star's life are scattered across the cosmos, enriching the interstellar medium with the building blocks of new stars and planets. Now, let me tease you with another mind-bending fact: supernova explosions can create neutron stars or even black holes. But how exactly do they do that? When the outer layers of the star are blasted away, what remains can be an incredibly dense neutron star, comprised primarily of neutrons, or if the remaining mass is substantial enough, it might collapse into a black hole, a region of space where gravity is so intense that nothing, not even light, can escape. Think about that. In the wake of a supernova, we are left with either a cosmic lighthouse or a seemingly impenetrable void. But we've only scratched the surface. The chaos unleashed by these stellar explosions doesn't just affect individual stars or stellar remnants, it permeates the vast cosmic arena. The shock waves generated by supernovae trigger the formation of massive molecular clouds, regions of gas and dust that can collapse under their own gravity to form new stars and solar systems. This cycle of birth, life, and death is a beautiful dance that has been occurring since the very dawn of time. Are you beginning to sense a pattern here? Now, let's consider another compelling aspect. Supernovae play a pivotal role in the evolution of the universe itself. They are part of the cosmic recycling process, where materials from older stars are repurposed to create new celestial bodies. This cyclical nature of stellar evolution is not just a poetic notion, it's an essential mechanism that enriches the universe with diversity. Without supernovae, the periodic table would look vastly different. Elements heavier than iron, like gold and uranium, are forged in the titanic explosions of supernovae or in the merging of neutron stars. Isn't that a sensational thought? The gold in your jewelry or the uranium used in nuclear reactors has its origins in the hearts of stars. But hold on a second, you may be asking, how do astronomers know what really happens inside these colossal explosions? The answer lies in both observation and theoretical modeling. Sophisticated telescopes equipped with advanced sensors capture the light and energy emitted during the event, while simulations based on the laws of physics allow scientists to recreate scenarios of star formation and death. The most spectacular of these observations, the light echoes from a supernova, reveal the aftermath in vivid detail, enhancing our understanding of the underlying processes. How incredible is it that we can piece together the life stories of stars millions of light years away? So where does all this lead us? In essence, supernovae are the universe's way of maintaining balance. They ignite a cosmic cycle, ensuring that the newly formed elements can coalesce under gravity to create new stars, planets, and ultimately, life. This interconnectedness prompts a fundamental question: are we merely made of stardust, or are we part of an intricate web that ties our existence to the life and death of distant supernovae? But what happens next? What do supernovae mean for the future of our universe? The second half of our journey will delve into the continued impact of supernovae on galactic structures, the potential for life, and even the mysteries of dark energy and the ultimate fate of the cosmos. This exploration will offer a profound perspective on our place in the universe, solidifying our connection to these celestial explosions while illuminating what they mean for our own existence. So, let's venture further into the wonders of supernovae and understand their pivotal role in shaping the vast tapestry of the universe. Hold on tight, because the revelations that await us will bridge the realms of science, philosophy, and our very understanding of life itself. The next segment will unveil the extraordinary implications of supernovae, igniting a sense of awe that might just change your perspective on the universe forever. Stay tuned as we peel back the cosmic curtain and explore the deep mysteries supernovae hold for us. As we delve deeper into the effects of supernovae, it is essential to recognize their influence on the grand structure of galaxies. The energy released during a supernova explosion is staggering, on the order of about 100 times the combined output of the entire Milky Way for a brief moment. Such immense energy doesn't just illuminate the vastness of space, it creates ripples that can trigger changes on the galactic scale. When a supernova occurs, its shock waves travel through the surrounding interstellar medium, compressing gas and dust and creating stellar nurseries, places where gas and dust can collapse under their own gravity to form new stars. Beyond these local effects, supernovae also play a vital role in the dynamics of galaxies themselves. The debris from these colossal explosions can interact with dark matter, influencing the gravitational pull and structure of the galaxy. This means that the very architecture of galaxies, like the spirals and clusters we observe, has been shaped in part by the deaths of massive stars. Moreover, supernovae contribute to galactic chemical evolution. As they distribute heavy elements into interstellar space, they enrich the gas clouds from which new stars and planets form. This is particularly fascinating because it explains why younger stars tend to be richer in heavier elements compared to older, population II stars that formed in the early universe. The cycles of stellar life and death contribute to a cosmic tapestry where each generation of stars builds upon the elements cast off by their predecessors. Such processes hint at the intricate dance of creation and destruction that defines our universe. But, amidst this stellar choreography lies an even deeper question pertaining to the nature of life itself. If a supernova's elements are essential to our very existence, could it be said that we are inherently connected to these ancient cosmic phenomena? The answer may lie in the delicate balance between chaos and order that supernovae represent. While they bring about destruction on a gargantuan scale, this destruction is not arbitrary, it serves as the womb for new creation. This interplay surfaces again as we consider the potential implications for life in the universe. The elements that constitute life on Earth, carbon, nitrogen, oxygen, phosphorus, are traceable back to supernova explosions. These elements undergo a stellar alchemical process, and as they disperse across the universe, they provide the necessary ingredients for life to emerge wherever conditions allow. Scientists have long speculated that in the expansive cosmos, other forms of life may originate under similar conditions, bathed in the stardust of supernovae. If we are indeed made of the remnants of long-deceased stars, then consider the possibility that every living organism, be it here on Earth or out there among the stars, is composed of the same fundamental elements forged in the hearts of dying stars. Yet, questions remain about the fate of our universe. While supernovae mark the death of individual stars, they also hint at something more vast, the ultimate destiny of all cosmic structures. The interplay between supernovae, dark energy, and cosmic expansion constructs a framework for understanding how we might define the fate of galaxies and even the universe itself. Dark energy is a mysterious force driving the universe's accelerated expansion. In this context, supernovae act as cosmic markers, allowing scientists to measure the rate of this expansion and comprehend its implications. One of the most surprising outcomes is that not only do supernovae impact the local interstellar medium, they also provide clues into the universe's expansion history and future trajectory. For instance, Type Ia supernovae, which occur in binary star systems as a white dwarf accretes material from its companion, have been instrumental in establishing that the universe is not just expanding, but doing so at an accelerating rate. Their consistency as standard candles allows astronomers to gauge vast distances and tie time frames into cosmic dynamics, thus revealing much about our universe's fate. Currently, theories point toward three potential scenarios for the ultimate fate of the cosmos: the Big Freeze, the Big Crunch, or the Big Rip. The Big Freeze postulates that the universe will continue to expand indefinitely until it reaches a state of uniformity, where stars burn out and galaxies drift apart in a dark, cold void. In contrast, the Big Crunch suggests all matter may ultimately collapse back into a singularity, reversing the expansion process. The Big Rip theory posits that the expansion would accelerate to the point where galaxies, stars, planets, and even atoms would be torn apart. In essence, supernovae feed into these narratives, their explosive deaths providing the raw materials and energy that modulate cosmic evolution. Hidden within their violent demise lies a tapestry woven from the threads of our past, pointing toward a complex future. To think that the remnants of stellar explosions could shape not just new galaxies but the very constants of physics we hold dear speaks volumes about their significance. Through these explorations, we uncover yet another critical aspect of supernovae, their role in triggering cosmic phenomena beyond the immediate aftermath of a stellar explosion. For example, it is believed that the uneven distribution of dark matter across the universe could be influenced by large-scale supernova events, which could contribute to gravitational clustering in the cosmos. Additionally, the study of supernova remnants offers critical insights into cosmic rays, high-energy particles that bombard Earth from distant sources, and which play a significant role in space weather. Understanding how these phenomena occur may help us better understand not only our solar system's dynamics but even the potential for habitability here on Earth. Each detail contributes to our comprehension of the universe's intricacies, imparting a sense of connection between these distant explosions and our very lives on this pale blue dot. Perhaps most importantly, supernovae challenge us to face existential inquiries about life, the universe, and our place within it. As we seek to answer the question of whether we are alone, we realize that our existence is not an isolated whim of nature but rather a profound echo of the starry cosmos, a grand cosmic play in which we too have a role. As we ponder the life cycle of stars, supernovae stand as a poignant reminder: death begets life. The universe is a grand cycle of birth, evolution, and rebirth, characterized by transformative events that define not just the destiny of galaxies, but the very nature of existence. From their brighter-than-galaxy explosions to the rich tapestry of elements they create, supernovae embody the beauty and complexity of the cosmos. In conclusion, supernovae are not mere astronomical cataclysms. They play a pivotal role in the cosmic narrative, shaping galaxies, driving elemental evolution, and providing vital clues to the fate of the universe. They connect the humblest forms of life on Earth to the celestial grandeur beyond, forcing us to confront our origins and what it means to exist. Each supernova serves as a bridge between destruction and creation, a reminder of our interconnectedness with the universe. As we stand in awe beneath a starry sky, we are reminded that within each pinprick of light, there exists a story of death and rebirth, echoing the poetic cycle of life itself. These cosmic events are intrinsic to both our understanding of the universe and our very existence as cosmic beings. So, the next time you gaze into the night sky, remember the spectacular violence and wonder of supernovae and the remarkable journeys that connect us to the cosmos. We are, indeed, made of stardust, and through the marvels of nature, we continue to explore, understand, and celebrate our place in the grand expanse of the universe. The cosmic dance of life influenced by the fiery passion of stars reminds us always that in the universe's majestic splendor, there is a place for us all. Keep looking up and stay curious.